All right, we are going to give you a little walkthrough on how to do a gizmo. So we start here. Anytime there's a paragraph, you got to read it. So atoms are tiny particles of matter that are made up of three particles. And then they put words in bold and highlight them. That means they're going to be used. So protons, neutrons, and electrons. We're going to be using those words. The element builder gizmo shows an atom with a single proton. The proton is located in the center of the atom called the nucleus. And here's another highlighted bolded word, nucleus. And here they give you the explanation, in the center of the atom. So the center of the atom is the nucleus. Now the gizmos are going to begin by kind of walking you through some features and showing you some things. And you're supposed to kind of figure things out on your own. So use the arrow buttons to add protons, neutrons, and electrons to the atom. Press play. And then we are supposed to notice which particles are located in the nucleus. So here's protons. Here's my arrows. It looks to me like protons are being added to this center of the atom, the nucleus. So let's get rid of protons. Okay. Neutrons. Well, they are going to the center of the atom as well, the nucleus. So it looks like protons and neutrons are in the nucleus. Electrons, well, they're not in the nucleus. They're doing this whole orbit thing that drives me nuts. All right, so let's get rid of those. And when we go back to the gizmo, what particles are located in the nucleus? Well, we can answer that question. And what particles orbit the nucleus? Well, not really orbit, but you're supposed to put in the electrons. Now, here we have a direction. Turn on show element name. So let's go back here. Here is show element name. Let's click it on. Right now, this is hydrogen. All right. What causes the element name to change? You can add or subtract. What can you add or subtract that will cause the element to change? So we add protons, and we are looking for this word here to change. So looks like changing the protons does change the element. Let's just make sure, though. Check the rest. Neutrons. Neutrons do not change the element, and electrons do not change the element. So it seems like only one of these will actually change what element it is. And so now we can answer that question. All right. Turn on show element symbol. So here's show element symbol, and we have an H for hydrogen. Okay. And element notation. So there's element notation. I've got these ones here. That's going to be important. All right. Three numbers surround the element symbol. The mass number, which is this top left number. Okay. The electrical charge, and there's no number if the element is neutral or balanced. And then the atomic number is this down here, the bottom left number. All right, watch how the numbers change as you add or remove particles. Okay, which number, look at the diagram, and my choices are mass number or atomic number, is always equal to the number of protons. So I'm going to be changing the number of protons, and I'm looking for which of these numbers is always equal to protons. Well, right now, no matter how many protons I have, you can see down here I've got 10. I've got a 10 for all of them. So I'm not getting a lot of information. So the gizmo wants me to go ahead and start playing with some other particles. So right now everything's at 4. Neutrons. Okay, well, my protons are 4, and now I'm down to only 2 numbers that have a 4. So let's add some electrons. All right. So now it looks like the only one of these 3 numbers that is going to be equal to protons is this bottom left number, which is the atomic number. So which number is always equal to the number of protons? Well, it looks like it is the atomic number. So my answer is just atomic numbers. They're not asking for a number answer. They're looking for a word answer. So 1 proton, the bottom left number is 1. 2 protons, the bottom left number is 2. 3 protons, the bottom left number is 3, and so on. All right, how can you calculate the number of neutrons in an atom using the mass number and the atomic number? So here's my mass number, the 9. Here's my atomic number, the 3. how can I calculate neutrons, which right now is 6, using this 9 and 3? So what can I do with the atomic number and the mass number to always get my neutrons? So right now, how can I use 9 and 3 to get 6? I'm going to make you figure that out on your own. Now let's add some protons. All right, I still have 6 neutrons. Can I use the same rule to get with 13 and 7 to get 6? Let's add some neutrons. Now I have 10 neutrons. Is there a way to use 17 and 7 to get 10? So they want you to figure out a rule using the mass number and the atomic number to always calculate neutrons. This is very important because you're going to be using this on the quiz. All right, part C. Which particle, and my answer choices are proton, neutron, or electron, has a positive charge? It makes the top right number get larger. So there's right now it's at +2. If I add electrons, my number gets smaller. So it doesn't seem like adding electrons makes that get bigger. Neutrons doesn't seem to have any kind of effect on that top right number, but protons does seem to make that number get larger if I add more protons. Let's go ahead and reset. All right. Which particle, proton, neutron, or electron, has a negative charge? And we kind of worked our way through that. And which particle doesn't seem to affect the top right number? So you can play around with protons, neutrons, and electrons and see which ones affect the top right number or not. All right. Here's a highlighted, bolded word. An isotope is an alternative form of an element. Each isotope of an element has the same number of protons. Otherwise, it would be a different element. Okay, so the element always has the same number of protons, but an element can have different amounts of neutrons. When you change the neutrons for the same element, you are getting what's called an isotope. The isotope is represented by the atomic symbol and the mass number, such as He4. So He4, He is helium, and 4 is the mass number. So if I can get helium to have a total of 4, it would be He4. Some isotopes are stable, while some are radioactive, which means that the atoms decay over time and emit radiation. So what are the stable isotopes of carbon? And there are 2. So the first thing I need to do is get to carbon. And the only way to get to carbon is to add protons, which will get me to different elements. So add protons, and there's carbon. All right. Oops. Carbon. All right. So I need it to say the word stable. Well, notice up here it says not valid. This isotope does not exist. And that's because right now I have 0 neutrons. So let's add some neutrons. Okay, this is a radioactive isotope of carbon. So C8 is radioactive. All right, let's but we are looking for stable. So let's add some neutrons. These are all still radioactive. Okay, stable. We see the word stable for carbon. This is carbon with a mass of 12. So C12 is one of my answers. And so I type it as C12. Okay. Now, your job is to find the other stable isotope of carbon. So just play around with neutrons until you do. All right. I need, for this one, the stable isotopes of nitrogen. So I need to change my element to nitrogen and start looking for stable versions. All right. So there's nitrogen. This is radioactive. Add neutrons or subtract neutrons until you find 2 stable nitrogens. So right now, N13, N-13 is radioactive, but I need stable. And then for this one here, list any 2 radioactive isotopes of oxygen, and there are many. So now I need to switch it to oxygen. Okay. Oh, here's one of my radioactive ones. So O14 is one of my radioactives. All right. So now here we get into our last section. Okay, good. How many electrons are in a neutral atom of lithium? So I need to change it to lithium, and I need to make sure that it is neutral. And I give you a hint here. You know it's neutral when there isn't a plus or minus number in the top right. So let's make it lithium. Oh, there's lithium. But right now, this is not neutral. It is got this positive 3 here. Well, to bring that number down, we need to add something negative. And we know that electrons are negative. All right, so here we have a neutral, because there's no plus or minus number, lithium. All right, so how many electrons are in neutral lithium? Well, we have neutral lithium. We can look down here. Neutral lithium has 3 electrons. So we just type in the number 3. How many neutrons are in an atom of Mg25? So we need to change this to Mg, and we need its mass number, the top left number, to be 25. So, oh, there's Mg. Right now, this is Mg18. We need this to be Mg25. I can't add protons because that would change my element, and it needs to be magnesium, Mg. What can I add to make sure that this 18 now becomes a 25? So you make your screen be Mg25, and then you can answer how many neutrons there's going to be. All right. What is the mass number of an atom that has 5 protons and 7 neutrons? Well, whenever you add a proton or a neutron, you are getting its mass number. So 5 plus 7 is 12, so the mass number is going to be 12. But just to make sure, let's go to 5 protons, 7 neutrons. So right now, protons is 12. And neutrons, we need to be 7. All right, so sure enough, the mass number right now is 12. You can use protons and neutrons combined to get its mass number. Electrons are so small, we don't really count them towards mass. All right, when an atom is charged, it is called an ion. How many electrons are in O and then a -2? Your job is to switch the element to oxygen, and instead of +4 or whatever's right here, you need to make this be a -2. Then you can answer the question. So switch this to, make your screen say O, -2, then look for your answer, how many electrons there are. And then same thing here, how many electrons are in Mg +2? Change your element to magnesium, change your charge, the top right number, to be +2, and then you can answer the question. That's pretty much it, and I hope that was helpful for you.